Hello learners and welcome to a natural sciences lesson. So today we're going to be looking at a series circuit, and within that we're going to be answering questions or practice questions and application questions that are based on this topic, being the series circuit. So starting with the practice questions, the first question given to us, it says, what is the function of the following components in a circuit? So the first component that we have is a battery. So we need to now answer this question by giving the function of a battery in a circuit. So a battery, we should know that it is used to convert chemical energy into electrical energy. Now remember that the battery, it is going to now be converting the chemical energy into electrical energy by pushing the electrons from one terminal to the other terminal. Now remember, as the electrons are moving from the negative terminal, flowing through the wires and back to the positive terminal, this is actually now known as your electrical energy. However, within the cell or within the battery, if you have more than one cell, within the battery, there's a chemical reaction that is taking place there. So which is why we're saying there's a conversion of chemical energy that is happening inside the cell into electrical energy, what is happening outside the cell as the electrons are moving from one point to the other. Second component is an ammeter. So we need to also know that this particular component, it is used to measure the current in the circuit. So when you want to measure how much current strength you have in a particular circuit, you need to use this device. And remember that this device must always be connected in series in a particular or in any circuit. You must always connect your ammeter in series in any circuit. Now, that ammeter that you're talking about, so we have our electric circuit. Our ammeter, it is going to measure our electrical current strength, and that current is measured in amperes with the symbol capital letter A. We always need to remember that whenever you see an A in any electrical circuit, know that that is an ammeter that is connected there, and it is connected in series, as we have said. It is going to measure the current strength measured in amperes with the symbol A, as we can see here. Then the third component that we need to give a function of is a voltmeter. So this voltmeter, what is it that we are using it for in a circuit? We are using a voltmeter to measure the potential difference in a circuit. Remember, the potential difference, or we can say we are going to be measuring the voltage in a circuit. Now, this particular device, remember, this one, the ammeter is connected in series. However, the voltmeter must always be connected in parallel because it has a high resistance. So whenever you are, let's say now we have a resistor being our light bulb, and you want to connect our voltmeter, it must be connected between 2 points across the resistor, or across any 2 points that you want to measure the potential difference of. Now, we're going to measure it across these 2 points. Now, this voltmeter, we've said it is measured in parallel, and then also it has a higher resistance. And the reason why it is measured why it's connected in parallel, it is because it has a higher resistance. Furthermore, it measures the voltage or the potential difference measuring in volts. The voltage is measured in volts and with the symbol V. So whenever you see a symbol V in any electrical circuit, know that that is a voltmeter which is connected to there, and it is connected in parallel. Remember, there's a difference between the two. One has a symbol A and the other one has a symbol V to denote ammeter, and the other one to denote a voltmeter. Next component, we have a resistor. We need to know what a resistor is used for in a circuit. This is an example of a resistor, in this case a light bulb. So why do we use a resistor in a circuit? So we are using a resistor in a circuit because you want to regulate or to control the current strength in a circuit. So if you want to regulate or to control the current strength in a circuit, you need to connect a resistor. Remember, the resistor, it is going to resist the flow of current or the flow of charge from one point to the other. So for you to measure the resistance, or how much resistance a resistor has, we're going to be making use of our we're saying that it is going to be measured in ohms. The resistance is measured in ohms with the symbol omega. We are using our resistor to measure the resistance of a circuit, in this case of this resistor, and it is measured in ohms, and the symbol for that it is omega. So we can have different symbols in a circuit that are denoting a resistor. We can have the first one, as you can see, the cross. We can also have a box, a rectangular box, or we can have another one that shows a zigzag. So all of these examples are actually denoting a resistance that is connected in a circuit. Should you see any of these symbols connected in a circuit, know that those are resistors and they are connected. Now in this case, they would be connected in series because we are looking at a series circuit. Now, question 2, we are told that electron current involves the flow of what? So the electron current involves the flow of the electrons. They are flowing from a certain terminal to another terminal. Remember that the electrons are now, in a conductor, they are moving in various directions. Once you start connecting a cell in that conductor, these electrons are now going to start moving from a negative terminal to a positive terminal. So they are moving from the negative terminal to the positive terminal. To the positive terminal of a battery in an external circuit. So the electron current involves the flow of electrons from the negative terminal to the positive terminal of the battery in an external circuit. Now, next question is asking us what instrument is used to measure current strength. So the instrument that we use to measure the current strength, we know it's an ammeter. So that current strength, it is measured, so the units now, in amperes. And remember the symbol is going to be A. So what you're going to be seeing in an electric circuit to show that an ammeter was connected there is the symbol A in your particular electrical circuit. Now, with that, we're going to move on to our next question, whereby now we need to answer the following questions about electric current still. We now need to explain how the instruments that has been mentioned should be connected in a circuit. So the instruments that they're referring to is the ammeter. So how should this ammeter be connected in a circuit? We're saying that an ammeter should be connected in series in a circuit. Why? Because it has low resistance. So we're going to be connecting our ammeter, the instrument that you've just now answered on question B. It is going to be connected in series because it has a low resistance. Should it have a high resistance, therefore it needs to be connected in parallel. Now, question D. What is the symbol and SI unit for current strength? So the symbol for current strength, so we have symbol, and we also have the SI unit. So our SI unit is amperes. So in full, we know that it is amperes and capital letter A. Now the symbol that you're going to be using for current strength, it is going to be amperes, or just A. Let's just say A. So the symbol for current strength is going to be A, and remember the SI unit is measured in amperes and is denoted by capital letter A as well. So with all of that said, before moving on to our application questions, we're just going to go for a quick short break, and I will see you just after this.